The next type, that is a sp hybridization. Now what is sp hybridization? We know that sp hybridization means 1s and 1p orbital overlap, undergoes mixing and recasting process and produces two sp hybrid orbital. Okay, the example for the sp hybridization. The example for sp hybridization is the formation of acetylene, that is ethine, HC triple bond CH. Now there is a two double bond, carbon-carbon triple bond. If carbon-carbon triple bond, then simply I can say that out of this carbon-carbon triple bond, the one will be the sigma and the two will be pi. And here this C is combining with the hydrogen. That means this bond is also going to be sigma. So carbon is forming total 4 bonds, and out of 4 bonds, 2 bonds are sigma and the 2 bonds are pi. This here the carbon undergoes sp hybridization because only 2 orbitals are required for the sigma bond. The remaining 2 orbitals are required for the pi bond, and the bond with the orbital which form pi bond never undergoes hybridization. And that's the reason that out of 4, only 2 are undergoing hybridization, that is 1s and 1p, and the remaining 2 of p orbitals will form pi bond. So carbon 6 configuration, 1s2, 2s2 to p2 again, 2 electron in s orbital, 2 in p orbital. Excited state, 1s2, 2s1 to p3. As I said, we have total 4 orbitals, 1s, px, py and pz, but since 2 pi bonds are required, so 2 orbitals will form a pi bond out of 4. So these 2 orbitals will not take part in a bonding. So s cannot be neglected because s orbital will never form a pi bond. So pi bond will be formed only by p orbital. So you have to choose 2 orbital only from p orbital. So 1s and 1p is left and they will undergo hybridization. So hybridized state, 1s and 1p, and this py and pz unhybrid. So we have 2 unhybrid orbital and this is sp hybrid orbital. Combining with the hydrogen whose atomic number is 1, so its electronic configuration is 1s1. Okay, now let's see the orbital overlapping. Orbital overlapping, the hydrogen. How many hydrogens are required here? 2. Overlap with carbon. From carbon, sp orbital and 2 unhybrid orbitals come together. So sp orbitals of carbon. This is sp means a linear geometry. First sp and this is second sp hybrid orbital. Each sp hybrid orbital is having electrons. Okay. Then this is carbon, only 2 orbitals. The 2 are left. These 2 are unhybrid. So unhybrid is also present there. These 2 are unhybrid orbital. Don't consider it as a p orbital. It looks like a p orbital, but the concepts are totally different. These 2 are sp and these 2 are py and pz, unhybrid orbitals. Okay. Now they will overlap. How many carbon? 2 carbon atoms is getting closer. The carbon, these 2 orbitals will form only sigma bond. Now where the sigma bond is forming between the 2 carbon atom. So first carbon, this orbital will overlap with the second carbon, the same orbital, and the remaining 1 orbital of each carbon will overlap with the hydrogen because there is a 2 hydrogen. So here the bonding will be something like this. First carbon atom, second carbon atom. Okay, in this case, overlapping takes place between the 2 carbon. So between the 2 carbon atom, this is going to be sigma bond. The 2 hydrogen, first hydrogen here, the second hydrogen will be here. Now the time to overlapping for the overlapping of unhybrid orbital. Each carbon is having 2 unhybrid orbital. The first carbon, the first unhybrid, the second unhybrid orbital of the first carbon. Similarly, 2 unhybrid orbital here also. Each is having two electrons. Now, this py and py will overlap together, and during overlapping, as I said, they will overlap on the upper as well as lower side. These two p orbital will also overlap together. Now here, when these two p orbitals overlap with each other, then they get the shape of the cylindrical shape. They get converted into cylindrical shape, means it's like something like this. The first you had observed such type of structure. So it's like a cylindrical shape because of the overlapping of p orbitals. Now here the bond angles, let's see. Now this geometry, carbon, triple bond, carbon, H, H. This is sigma, sigma, sigma bond. These two are pi bond. There is only one angle possible, this angle, HCC angle, and it is a linear geometry. HCC, that means this angle. So it is going to be a linear geometry. So this is about the acetylene. One more thing, that is, see, in case of alkane, that means if I am drawing CS3, this is alkane, sp3 hybridization. In case of alkene, CH2 double bond CH2, sp2 hybridization. In case of alkyne, when the carbon form triple bond, sp hybridization. Here the s character, sp3 means 4 orbitals. So 4 orbital divided by 100, that is each orbital have 25% character. So there is only one s orbital, so s orbital characteristic is 25%. Here s orbital, total 3 orbital. So 100 divided by 3, each orbital will have 33, 33, 33. That means s orbital characteristic will be 33.33%. Here in case of sp, each sp or s orbital characteristic is 50%. And as the s character goes on increasing in a carbon or in any molecule, the electronegativity goes on increasing. Means here I can say from these 3 carbon, all 3 are carbon atom, but here the carbon electronegativity is very high because of its more high s character. In this case the electronegativity is less, and in this case the electronegativity is least from all 3. So just keep in mind that from the hybridization we can say that the carbon which is forming a single bond undergoes sp3 hybridization, carbon which forming a double bond undergoes sp hybridization, the one which form double bond sp2 and the one which forms triple bond undergoes sp hybridization. Now let's see the formation with the help of animation. Here you can see that we are having 2 carbon atoms. Each carbon atom comes with each carbon atoms comes with 2 unhybrid orbital. Now let's see that these 2 are now the overlapping. During overlapping, the first carbon atom, the second carbon atom, sp2 orbitals overlap. The other 2 sp2 orbital is overlapping with the hydrogen, and the unhybrid pz and py orbitals, you can see that here they are overlapping with overlapping laterally, and they are forming a finally ethylene molecule. So this is the geometry of, this is the structure of the ethylene molecule. Okay, now the next is the second example for the same, that is sp hybridization. It's formation of BeCl2 molecule. BeCl2 molecule or BeF2 molecule, I can say. So here let's see, beryllium, whose atomic number is 4, its electronic configuration is going to be 1s2, 2s2. 1s2, 2s2 means there is a no unhybrid orbital. So there is a 1, 2p orbital also. That's a different thing, that p is having no electron. I write p because I know that the next step I have to write the excited state. So where the electron will excite, so I can say that it will excite to 2p orbital. Then beryllium in excited state, it can be done as 1s2. The electron from 2s will jump to p. The jumping or the excitation is taking place because here the number of half-filled orbital and the number of bond does not matches. Number of half-filled orbital is 0, but it is forming 2 bond. So now we have 2 half-filled orbitals, so will form 2 bond. Then chlorine, whose atom, so hybridization, in hybridized state I can say if there is only one s and only one p orbital, so sp hybridization. Now here the sp hybridization doesn't mean there is a pi bond. Here we have only 2 orbitals, that's why it undergoes sp hybridization. Now let's talk about the chlorine, whose atomic number is 1s2, atomic number is 17. So configuration is 1s2, 2s2, 2p6, 3s2 and 3p5. So here we have s2 and p5 electrons. So I can say that from here only half-filled orbital is this pz orbital. So pz will take part in a bonding. So chlorine and beryllium, they are overlapping with each other. So let's see for chlorine. From chlorine, pz orbital will come. Two are completely filled, one is half filled. This is about the chlorine. How many chlorine? 2 chlorine atoms are there, which is getting overlapping with the pz orbital. Pz from pz, which is overlapping with the beryllium. Beryllium, from beryllium, we are having sp hybrid orbital. So this is sp hybrid orbital. Each of them is sp orbital. Each of them have 1 electrons. Okay. Now the one chlorine, I'm again drawing only for pz orbital during the overlapping. So first chlorine overlap here, and the second chlorine is also getting overlap here. So this is BeCl2 molecule. Here the in case of BeCl2 molecule, the bond angle is going to be 180 degree. The geometry is linear. Same thing here also, the geometry is linear. So this is about the BeCl2 molecule. So these are the two examples I can say for the sp hybridization. The carbon undergoes sp hybridization because of the formation of double bond. Here such double bond formation doesn't take place. Here it undergoes sp hybridization because there is only 2 orbitals. If there was one more orbital, it may undergoes sp3 also, but only sp2 or hybridization. But here currently it is sp hybridization.